All right. This little half-moon structure sitting up on the surface of these mucus-secreting cells is called serous demilumen. Okay. My pointer is in the lumen of what structure of this gland? The duct. Very good. Right, you can see, so here we actually have quite a few cross-sections through ducts. We have quite a few acini that are purely serous, then we have these mixed acini that have both serous and mucus. Now, contrast that. To this. So if I said, name this gland, compound multicellular gland. Where's my next person? What else can it be called? What is the product coming out of this gland, just given the color of the cytoplasm here? Serous, okay, this is another serous gland. Now these happen to be zymogen granules in this one. I have a question all the way at the back there. I saw a hand. This I would like to have seen compound multicellular gland, okay? But if you called it a serous gland, that would be fine. But what it is definitely not is it's not any kind of simple gland, and it's definitely not a mixed gland. Yes?
Is the sebaceous gland just a form of serous gland? No.
Sebaceous glands are not serous glands, all right? Because the kind of secretion that you're going to see in a sebaceous gland is different. So if we now take off our lab hats and we look at our lecture hats, all right? 3 different kinds of secretion. Holocrine, merocrine, apocrine, all right? Sebaceous glands undergo what kind of secretion? Holocrine. In other words, the whole cell is actually pinched off and secreted. So that's when we were looking at those sebaceous glands, you could see we really didn't see a lumen. That's because the secretory product is essentially cells, okay? Whereas these guys are going to be, what kind of secretions are these guys going to do? Merocrine, okay? Because they're not pinching off the top of the apices. Do we remember which one we gave an example of the apocrine? It was a special kind of sweat gland where the whole plasma membrane gets pinched off at the top.
The stinky ones.
The stinky ones, yes.
Did we already look at a sebaceous gland so far?
We have. Do you want me to go back and look at it
Is
again?
that the hair follicle one?
That's the hair follicle one. Yep.
How do you know the difference between the compound and simple gland?
So the compound gland, there's no ways that at this magnification, and remember, when you're thinking about what magnification is, you got these things on, look at the nuclei, because the nuclei don't vary a lot between cells. Cells can be all sorts of different sizes and shapes, but generally their nuclei are about the same size. This happens to be a rounded cell, so its nucleus is nice and round. Fibroblasts have those flat nuclei, but if you take that nucleus and imagine these nucleus and squishing them flat, that would be a fibroblast nucleus, but the nucleus is still about the same size. It just happens to be longer and much skinnier, all right? So the nucleus, if you look at this is quite high magnification, but it's not high enough for this to be some kind of simple gland, because even at this magnification, a simple gland should only fill up not even a quarter of this area, okay, at this magnification. Right, have we done epithelium and glands to death?
Yes.
That was not smart. Technically, because we're still doing glands, we want the terms, the structures and the terms of the glands simply without giving it their reasons. But because we have to teach you about
Is that your point? Is that
Yeah,
what
you
you're
put her on.
No, like an hour and a half. So
All right,
just where an hour. Do stuff, right?
if I put a pointer and I said, name, this is the nucleus of what kind of cell? Fibroblast. Why?
Spindle shape.
Spindle shape, long and skinny. Okay.
The cytoplasmic stains just like the coloring.
And the cytoplasm is staining very similar to the collagen fibers, correct? Okay, so that's why it's really, the cytoplasm is not that visible here. All right. Now, I would have to, given that when we're looking at this, I'd have to say this is a very specialized connective tissue. If I said name the connective tissue, this is a toughie.
Embryonic?
It is embryonic tissue, it is also mucous connective tissue, but remember this, what does this also look like? Loose connective tissue, okay, so in an exam I'm not going to ask you, guess what this is, all right?
What would you
I'll say, in this umbilicus, what is this tissue, okay?
So what would you say? What would you say? Mucus connective tissue?
This is mucous connective tissue.
Oh yeah, because it's not like
If you said embryonic connective tissue, I'd probably give you that too, because it is.
And why is it that it has a lot of water?
All right, so why does it have a lot of water?
Placenta.
Oh. So keep it straight.
All right,
Kinks.
remember my hose pipe analogy for those of you who were around when we did that in the lab? All right, when you're watering your yard and you want to stop the water and then go on to the next pot, for example, what do? You kink the hose and that stops the water flowing, right? This is an umbilicus. This is the lifeline between your fetus and the mother. What happens if you kink the umbilical cord? Okay, no blood supply. So that we do not want that to happen. And your fetus, especially as it gets up into the 6, 7, 8 months, is doing a lot of moving around and rolling around. And so the last thing you need is to have that umbilicus get kinked. So this mucous connective tissue has a tremendous amount of proteoglycans in it, lots of adsorbed water to it, so that it can actually remain turgid or stiff. But remember, you don't want something that is so stiff that you're constricting the blood vessels themselves. Okay, so it needs to remain turgid. And of course, for it to be turgid, what is this going to have on the outside? What kind of epithelium is going to be on the outside of this structure? It's a toughie. It's a type of mesothelium, okay, but this happens to be a very thickened mesothelium.
Oh, is that?
But remember, what's happened here is the same thing that we're seeing we can actually see all the collagen fibers here, although technically when we look at this, when it is fully saturated with water, we should not be able to see those collagen fibers. During the processing, what we've done is we've taken all that water out, so this umbilicus has shrunk tremendously. So those nice flat mesothelial cells that we would have had on the outside surface have all kind of collapsed together, right? But this would